Question: an airplane flies to 76.9 kilometers west, 76.7 degrees toward south, from Edmonton to Calgary, and then continues 75.1 kilometers west, 11.45 degrees toward south, from Calgary to Vancouver. Using components, calculate the plane's total displacement. We define north as positive y direction and east as positive x direction. Then for vector to 76.9 kilometers west, 76.7 degree toward south. This is west and also negative x direction. And this is south, also negative y direction. The direction of the vector is west, 76.7 degree toward south. So this is the vector. This is the vector delta d1. This is the vector delta d1x. And this is the vector delta d1y. And this angle is 76.7 degrees. From the graph, we can know that the magnitude of the vector delta d1x equals the magnitude of the vector delta d1 multiply cosine 76.7 degrees. And this equals 276.9 multiply cosine 76.7 degrees. And this equals 63.7 kilometers. Then the vector delta d1x is negative 63.7 kilometers. It's negative because its direction is the negative x direction. Then the magnitude of the vector delta d1y equals the magnitude of the vector delta d1 multiply sine 76.7 degrees. And this equals 276.9 multiply sine 76.7 degrees. And this equals 269.47 kilometers. Then the vector delta d1y is negative 269.47 kilometers. It's negative because its direction is negative y. Then for vector delta d2, 675.1 kilometers. The direction is west, 11.45 degrees toward south. Again, this is west, also negative x direction. And this is south, also negative y direction. The direction of the vector delta d2 is west, 11.45 degrees toward south. So it should be this way. This is the vector delta d2. This is the vector delta d2x. And this is the vector delta d2y. And this angle is 11.45 degrees. So from the graph, we can know that the magnitude of the vector delta d2x equals the magnitude of the vector delta d2 multiply cosine 11.45 degrees, and this equals 675.1 multiplied cosine 11.45 degrees, and this equals 661.66 kilometers. So the vector delta d2x is negative 661.66 kilometers. It's negative because its direction is negative x. Then the magnitude of the vector delta d2y equals the magnitude of the vector delta d2 multiply sine 11.45 degrees, and this equals 675.1 multiply sine 11.45 degrees, and this equals 134.02 kilometers. Then the vector delta d2y is negative 134.02 kilometers. It's negative because its direction is negative y. Now we can get the vector delta dx equals the vector delta d1x plus vector delta d2x. This equals negative 63.7 plus negative 661.66 and equals negative 725.36 kilometers. And the vector delta dy equals the vector delta d1y plus the vector delta d2y and equals negative 269.47 plus negative 134.02 and equals negative 403.49 kilometers. Now, this is the vector delta dx, and this is the vector delta dy. Now this is the vector delta d. This angle is theta. This is a right triangle. So from this triangle, we can know that the magnitude of the vector delta d equals square root the magnitude of vector delta dx square plus the magnitude of vector delta dy square. So this equals square root 725.36 square plus 403.49 square, and this equals 830.03 kilometers. And the angle theta equals arc tan the magnitude of the vector delta dy over the magnitude of the vector delta dx and equals arc Edmonton, 403.49 over 725.36, and theta equals 29.09 degree. We know this direction is west, and this direction is south. So at last, the total displacement delta D is magnitude 830.03 kilometers. Then the direction is west 29.09 degree toward south.